This lesson was also included in the Essential Skills video in this series, but it's also included in this video as a recap. A full understanding of the date serial number concept is essential in order to understand the date and time functions that will be introduced in later lessons. Excel stores dates in a very clever way. Understanding Excel's date storage system will empower you to use date arithmetic. You can use date arithmetic to compute the difference between two dates in days, or to shift date ranges by a given time interval. First, we need to look at how Excel stores dates. Dates are stored as simple numbers called date serial numbers. The serial number contains the number of days that have elapsed since the 1st of January 1900, where the 1st of January 1900 is the number 1. An interesting shortcoming of Excel is its inability to easily work with dates before 1900. Excel simply doesn't acknowledge that there were any dates before this time. If you work with older dates, you'll have to work around this limitation. The next concept to understand is that in Excel, every time is a date and every date is a time. This one's quite an eye-opener. We've already realized that the 5th of January 1900 is stored as the number 5. So what would the number 5.5 mean? It would mean midday on the 5th of January 1900. That's because the 0.5 part of the date serial number means halfway through the day, and halfway through the day is of course midday. When you enter a pure time into a cell, the time is stored as a number of less than 1. Excel regards this as having the non-existent date of the 0 of January 1900. When you enter a pure date into a cell, the time is stored as midnight at the beginning of that day. So now that you understand the concept of date serial numbers, let's test them out on a new blank worksheet. So I'll click File on the ribbon, and then New, and then double-click the blank workbook template. In cells A1 to A5, I'm going to enter sequential numbers. By entering the number 1 in cell A1, and then using the right mouse button to autofill down to A5, and when I release the button, click Fill Series on the shortcut menu. In cell B1, I'm going to enter a formula that will display the value in A1. By entering the equals key on the keyboard, click on cell A1 once, and then press the Enter key. And I'll now double-click on the autofill handle to autofill to the end of the range. In C1, I'll do exactly the same thing, equals on the keyboard, and click on cell A1 to display the same value in C1 that's currently displayed in A1. I now press the Enter key again, click on cell C1, double-click on the autofill handle to autofill down. So I now have a situation where if I change a number in column A, I'll see the same number displayed in column B and column C. I've done that because in column B, I'm going to format those numbers to display as dates, and in column C, I'm going to format the numbers to display as times. It's important to realize that the number is still the value in the cell. I'm simply formatting it to display as a date. So I select cells B1 to B5, right-click and choose Format Cells from the shortcut menu. I'm then going to choose the Date category, and I'm looking for a date that shows the year as 4 digits. If I scroll down, I can see one here, March 14, 2001. But it's possible you won't see a date showing the year as 4 digits, because the types I see in this box will change depending on my locale. For example, I'll change to the UK locale now, and you can see that in the UK locale there is a date format with 4 numbers. It doesn't matter which format you choose, as long as it has a 4-number year. I'll now click OK, and unsurprisingly, you can see that 1, 2, 3, 4 and 5 relate to the first 5 dates in 1900. Let's do the same now in column C, but this time format the numbers as times. So I right-click and choose Format Cells as before. This time I'll choose Time from the category. Bear in mind what I said about the locale influencing the times. I know there's a nice time in the US locale. There it is, the 24-hour clock showing 13:30 as an example. I'll now choose that first type and click OK to display the time as a 24-hour clock. And because all of the numbers in column A are whole numbers, all of the times in column C are displayed as 0, meaning midnight at the beginning of each date. Supposing I changed the value from 3 to 3.5 in cell A3. You'll now see that column C3, when I press the Enter key, shows 12 o'clock midday, because halfway through the day is midday. Let's try another one, 4.75 in A4. When I press the Enter key, you'll see that the time is now 1800. That's because 6 o'clock in the evening is 3/4 of the way through a day. And finally, let's display a time without a date. In A1, I'll type 0.5, and when I press the Enter key, you'll see that mythical date of the 0 of January 1900. In other words, the serial number 0.5 is regarded as only a time and not containing a date at all. Now that you've got the hang of these date serial numbers, we can perform some date arithmetic. If I was to type in cell B7 the 1st of January 1900 and in cell B8 the 1st of January 2000, I can compute the number of days in that century simply by subtracting one date from the other. Let's do that. Equals, and then I click on cell B8, minus, and I'll click on cell B7. Now you know that the 1st of January 1900 has the serial number of 1, and that the 2nd of January 1900 was 2, and the 3rd of January 1900 was 3. And the numbers keep counting up until the 1st of January 2000 will contain a large number that contains the number of elapsed days between those two dates. So when I press the Enter key, you can see that there were 36,525 days in the century. There's no need to save this workbook, so I'll click the Close button and then click Don't Save. You've now completed Lesson 3.7, Understand Date Serial Numbers.